view it. All right, so first things first, for those of you who don't know, my name is Christian Guerrero. I'm the project manager. For this year at UIC for the EMBS chapter. Hi, Haley. Haley, who actually just joined, she's our outreach chair. So thanks for coming in, all of you guys. First of all, I hope you guys are all doing well this week and this semester, staying healthy, staying active. So about the project, for those of you who don't know, basically the project's called Making Waves, and the point of it is to learn how to analyze EEG data using a toolbox known as EEG Lab. And it's a pretty powerful toolbox. I'll get more into that later. But so for this semester, since we are pretty late into the semester, in these next couple of weeks are going to focus mostly on tutorials, learning how to use EEG Lab. And for those of you who are freshmen and maybe some second years, I don't really remember the order of the classes, who don't really know about the basics of like what signal analysis is and what brainwaves are and EEGs are. We're going to go over some basics today and kind of talk about all that stuff. So for those of you who might already know, feel free to bear with me if it's okay if you understand the stuff already. And then next week we're going to start getting into the bulk of the tutorials for EEG Lab. All right. So, all right. So I'm going to go ahead and pull up slides for today.
Also, Christian, if anyone wants it, I do have the textbook for $240. Not that you couldn't find it online anyways, but I don't know who's freshman here or sophomore, or who's taken 240 yet, but 240 is the signal processing class.
Mm-hmm. Oh yeah, that's true, guys. Side note, maybe we should do something like that for EMBS, but you can find most things online, which is pretty great. All right, can you guys all see my screen?
Yep.
Perfect. So starting off, I already introduced the project. So starting off with what are brainwaves? So, since this whole project is focusing on brainwaves, it's kind of important to understand what they are. So basically, the most important part, arguably, of our body and essential to everything, to being alive, to perception of life, thoughts, and emotions, is the electrical communication between the neurons in our brain. And brainwaves specifically are a result of synchronized electrical impulses, because of how small they are and how small the voltage is. It's really hard to detect single neurons, but so we can detect mass neurons firing simultaneously. And so brainwaves are the signals that we can detect from these masses. And like all signals, which you'll learn if you haven't already, they can be described by their amplitude. In our case, it's usually microvolts or millivolts, and their frequency, which is hertz or cycles per second. Brainwaves can generally be categorized into 6 groups, where each group has a different range of frequencies and associated states of mind or being. Infralow are the lowest brainwaves, and frankly, we don't really care about those because they're really hard to detect. EEG Lab isn't made for that, and there's not a lot of studies that have occurred with infralow, so we don't really know what they're for yet. Delta waves are the lowest that we care about. They go from 0.5 to 3 hertz, and they're mostly associated with a deep sleep and also dreaming. Theta waves are the second, and they go from 3 to 8 hertz, and they're usually associated with someone who's very experienced in meditation. That's kind of what their mind is when they're meditating. Also daydreaming, and kind of when you're drowsy, as most of us might be. Alpha waves, 8 to 12 hertz, are a more relaxed state. Someone, for any who practice yoga or do some sort of creative outlet, this is mostly what your brain is going through when you're in this state, something that you're used to doing, even like brushing your teeth. Beta waves are the ones that we see most often, from 12 to 32 hertz, and they're the normal consciousness of the brain, and they are mostly active during active thinking. The gamma waves are the highest frequency brainwaves, which are most associated with heightened perception, learning, and problem solving. The way we measure these brainwaves is with that very long word, I believe, electroencephalography. or EEG for short, which is basically a machine that records the electrical activity in the brain via a couple of electrodes, a bunch of electrodes that you place around the scalp. And then right there we have a picture, and it's generally what it does. So the importance of measuring brainwaves is that they can be really, really useful. You know, they are indicative of a lot of things, and sometimes they can help diagnose and sometimes assist in developing the process to treat certain disorders. Most commonly, they're used to diagnose epilepsy, tumors, traumatic brain injuries, any inflammation of the brain, stroke, and they're often used to diagnose sleep disorders. Then, here we go. We have a couple of example EEGs, which this is actually one EEG for the same person. Do any of you guys want to take a guess as to what exactly is going on here? Or any of you, I don't know, I doubt any of you guys know immediately. But anyone want to take a guess as to what the before and after is? I didn't think so. But long story short, the left, the before, is actually someone sober. And the one on the right is someone who a couple minutes after they've smoked weed. And I just thought it was kind of funny, you know. I don't know if I'm not going to ask if any of you guys have done it, but traditionally you think. Well, sorry,
so Christian, is it accurate to say that the left is your brain not on drugs and then the right is your brain on drugs?
Yes,
okay.
Absolutely.
Thank you.
Yeah, thank you for that. But yeah, so, you know, traditionally most people believe that weed, specifically THC, there haven't been studies much done on CBD, which is the second most common component in marijuana. But traditionally they believe that it calms you down. But the science and your brain actually kind of shows otherwise. You know, medically speaking, your brain kind of looks more similar to someone with schizophrenia when you're high. All right. So getting into the actual bulk, the main part of this project is going to be about signal processing and understanding signal processing as it relates to brainwaves. And signal processing, essentially what it is just the manipulation of a signal, in our case, brainwaves, to extract information. And it can be generally broken down into 3 different steps, which are signal collection, which unfortunately, since we are virtual, we won't be focusing too much on. We do have the equipment. EMBS does have and Dr. Esma Beghi, our faculty advisor, does have the equipment to collect this information. So hopefully next semester, if we're in person, or if not, whenever we go back. But the second step is signal pre-processing, which is arguably the most important step, because that's the step that it involves the most work and the most time. That's what you'll learn, and that's really what you'll learn in 240, which is basically, so it's going to be a lot of amplification, filtering, noise reduction, and stuff of the like. And the last step is the actual signal analysis, where you try to extract and infer something from the data that you collected. So just a little bit more detail. I've been talking about this word signal a lot, but so generally the actual definition of a signal is just a function that describes the change of a physical quantity, in our case, voltage, millivolts, over some independent variable, usually time. And a signal can be continuous, which means that at every point in time, at infinitesimally small points in time, it has some value. And then it's also called an analog signal. A discrete signal is a signal where you have readings of the signal at specific points in time. So say every 2 seconds. And that's usually called a digital signal, because that's what computers can understand, what can they communicate in. Do you guys, everything make sense so far? All right, sounds good. So signal collection, the 2 most important things that we need to understand for EEG Lab is sampling, which is the process of converting a continuous signal into a discrete one by sampling it at a specific number of times, which is called the sampling rate, which is literally the numbers of samples that you collect per second from the signal. And if you can see over there on the right, there's 2 signals and the dots represent how often it's been sampled. And sampling is super important, especially your sampling frequency. It's important to reconstruct the signal. So if you can see on the top one on the picture on the right, that's a signal that's been sampled enough times where you can accurately reconstruct the signal. If you reconstruct it, if you sample it too little times, if your sampling frequency is too low, then you can get any number of signals that might not necessarily be the signal that you recorded the first time. And so this is generally known as the Nyquist sampling theorem, which if you guys haven't learned, you will learn. And it basically says that your sampling frequency needs to be at least 2 times greater than the highest frequency contained in the signal being sampled. In practice, this really ends up being more like 10 times or something, but the theorem says 2 times. So pre-processing is the step, like I said, the most important step, and the step that we're going to focus on a good part in this tutorial and next tutorial, sorry. And it basically just involves any type of instrumentation or work done to prepare your data for analysis. And generally this involves amplification, which is the picture on the left, literally just taking your data and applying some sort of usually like voltage to it so that you can get a greater output. Noise reduction and filtering, which is literally the process of, especially in the brain, we can only record so precisely. So there's a lot of extra information that we record that we might not necessarily want, and that might not be part of the signal that we're trying to record. And so that's generally referred to as noise. The better your machine is, the less noise you'll have, but noise is kind of inevitable. So it's important to understand how to reduce the noise and also how to filter the noise. Generally part of that is, the most common example is in the United States, most of our electronic equipment runs on 120 volts, I believe, so there's noise at 60 hertz and noise at 120 hertz. So the harmonic signals of all the electrical equipment that we use. And so generally there's noise at 60 hertz. And so we want to reduce that noise. And that's usually done with filters, which you'll learn more about in electrical engineering. Victor probably already knows, and some of you probably do too. But so those four things on the bottom right are the 4 most common filters that we as bioengineers will most likely use. And they're pretty intuitive. The low pass, high pass, band pass, and band stop, they all just kind of let a certain frequency pass. Low pass lets those frequencies below a certain point pass, and so forth. And they're not as ideal in practice as they are in these pictures, but they work. And finally, we also have data extraction, which for our purposes is usually refers to the process of taking specific time points of data and taking them out from the rest of the data so that we can focus on a specific time. And in EEGs, these specific time frames are called epochs. Then signal analysis, which is a thing we'll get to later in these tutorials, is literally just trying to analyze a signal in order to understand and deduce some information from it. For EEGs, it could be some sort of sign of epilepsy, or if you are high or not. That would be a very expensive breathalyzer, but be kind of fun, actually. Not getting pulled over, but whatever. But so signal analysis is usually done in a time domain. Since we record the frequencies in the time domain, it's usually it's usually pretty easy to do that. But for some signals, you can analyze the same signal in the frequency domain. And the process of converting a time-dependent frequency to a frequency-dependent frequency is usually done with this thing called a Fourier transform, which is a pretty complex mathematical thing that someone smart came up with. But what it essentially does is it takes a signal and deconstructs it so that you can see the frequencies contained within your signal. And in MATLAB, there's a command called FFT, which stands for Fast Fourier Transform, which that's the one that we'll most commonly use and the one that we're going to use in EEG Lab. And over here on the right, if you can see, on the top, we have the time-dependent signal. So we could probably analyze this, but if you had, in our case, 16 or 32 channels of data, might get hard. So, and then the bottom, that's after the Fourier transform. So as you can see, the x-axis is now frequency instead of time. And then right here, these spikes basically correspond to whatever frequencies were contained inside of the top signal. All right, so that's pretty much it for the actual background and basics. There's a lot more that we could talk about, but for our purposes, this is enough for now, and you guys will learn much more throughout UIC. But does that kind of make sense for everyone for now? Yeah? Any questions at all? Sounds good. All right. So moving on to what is EEG Lab. So EEG Lab is a MATLAB toolbox developed by the Swartz Center for Computational Neuroscience. And it's a very well documented, very well used and funded toolbox. And it's pretty straightforward to use, but it's meant for processing electrophysiological data such as EEG. And you can do it via a graphic user interface if you're not really used to MATLAB. And that's what we're going to be doing for this tutorial. Or you can also do it in scripting, which is like actually coding something and writing out your actual code and what you want to do with the EEG data, which that's pretty out there, but we might get there. Okay, so let's see. I'm going to stop sharing real quick. So on that Google sheet that I shared with you guys, if you guys go to the second sheet, there is a column labeled EEG Lab with a link. And then if you go on there, that's where you can go ahead and download EEG Lab. I'm going to show you guys how to do it right now, just to like really quickly go over it and how to actually download it. So I'm going to share my screen real quick again, but if you can figure it out, absolutely go ahead. Nope, all the power to you. Okay, you guys see my screen again?
Yep.
Perfect. Thank you. So this is the EEG Lab website. It's also free, which is great for us, and it's pretty great. So over here on the left, you can see they have workshops. So if you guys ever want to go to workshops, I think I don't know if they're having any this semester, but they're there. Then you can see all the documentation, tutorials, and for our purposes, downloading. So then you'll have to fill out this like little thing, which I don't think it really matters what you put in, and then accept the terms. And if you want emails, go ahead and do that. Then after you do that, you'll be taken to this page right here, which is the actual download page. And you can click this first link to download it. And you can also download a compiled version, which saves you a bit of time later with the zip file or whatever operating system you have. But so yeah, you can download it, and then I will show you guys the actual process once you download it. And then I'm gonna wait like 2 minutes. Are you guys gonna download it right now, or would you rather keep going through the tutorial?
I'd rather go through it just because. Are we posting this on the EMBS website?
Yes, I'm gonna post. We're gonna post. It's the whole thing is being recorded, so I'll go ahead and post it after.
Nice.
All right. Well, if everyone's okay with it, I'll keep going. But so once you've downloaded it, it might be important for you to. It's going to be important for you to understand where you download the folder. So in my case, I have this folder just labeled MATLAB. So what you're going to do when you actually enter in MATLAB, if you didn't download the compiled version, then you need to set your path so that MATLAB can use EEG Lab. And if you download the compiled version, I don't think you need to set your path. If anyone downloads the compiled version, correct me later if I'm wrong or anything. But so you can set your path one of two ways. There's literally a folder here that says, there's a command here that says set path. The way I did it, I don't know if you guys can follow this way or you guys can do the set path, but if you go to this white bar right here.
So we're still seeing the download EEG Lab thing.
Thanks, Haley.
Mm.
Okay, that better?
Yep.
Thank you, Haley. Okay, sorry about that, guys. So once again, the way you can do your set path with this command right here, and this is, you're gonna need to set your path if you choose to download the zip folder and not the compiled version. I don't really know how to use this one, but the way I set my path works pretty fine. So this white bar right here, right above the command window, or should be here, regardless of how you have your setup. You go in here, obviously that's my computer, and then you can kind of use your current folder to find your way to it. So to find your way wherever you put the folder. So in my case, it's going to be a lot of going to MATLAB. Then you have a folder for EEG Lab, and you're going to go into the EEG Lab _ current folder. And then once you're into the current folder, you've pretty much set your path, and then MATLAB can actually go ahead and run EEG Lab. And so once you set your path, running EEG Lab is actually pretty easy. You just go into your command window and you just type EEG Lab. If you have the compiled version, I believe that you just need to type EEG Lab and it'll do it automatically for you. So that saves some time. But so you type in EEG Lab and then it's going to do a bunch of things. And then this pops up. So this blue square is basically is EEG Lab. This is the graphic user interface where we're going to spend most of our time for these tutorials, simply because.
I don't think the GUI popped up.
No? Oh.
No.
God. Oh, that's because I can. Oh, there we go. Okay, now you can see it, right?
Yep.
God. I understand why professors have a hard time with this. Thank you, though, Haley.
Zoom University.
Yeah, for real. And they're still going to charge us full price. But that's besides the point. Anyway, so this blue square, this is basically the GUI for EEG Lab. And you can do anything that you can do scripting or writing the code for it, you can do in this GUI right here. So for our purposes right now, if once you download EEG Lab, you do get, let me just go into, so if you go to the current folder, can you guys see this? They have a folder called sample data, and then this is all the data that they provide for you to follow along with tutorials and to just generally play around with and get a hang of it. So that's the data that we're going to use. So for here, you can go into File, Import Data, and they have a bunch of different plugins and things that we can use to import different files of data and different types of EEG files and raw data. And basically all of these are plugins that we can download. I think we're going to go over that next week. But for now, we're going to go to Load Existing Data Set. And then right here, I already have the sample. You can just find the sample data folder. And we can open, in this case, we're going to open the EEG data.set. And .set files are EEG lab files. So they're going to be pretty easy to open. So we just click Open. And then it'll go ahead and open it. And as you can see here in the GUI, now it's changed from no data set to continuous EEG data. And generally, this is going to display general information about our data set. So in this case, you know, they, and all this data, if it's not immediately imported, not immediately obvious, it can be imported into from different files. You know, most publicly available EEG data has all these parameters already in, but if not, they're in separate text files that you can load in with your data. But So here we can see how many channels or how many specifically electrodes they used to record this data. The epochs, the events, which are the actual stimuli that happened during this experiment, sampling rate, the epoch, in this case, it's all the data since we haven't extracted our own epochs, references, which is like a reference electrode. And here we also, this is one of the other things that you can definitely import. You can also view the channel locations. And so that's just general information about the EEG data. And then there's a lot you can do. So I suppose the most impressive one, and the one that is the coolest in my opinion, if you go to plot, then there's a couple different ways to plot your data. Probably the most common is scroll. Can you guys see this?
Yep.
Perfect. Yeah, so this is your EEG data. Over here on the left, these are all the electrode names and the channels that recorded the actual EEG data. These lines are the events labeled that for what happened during the experiment. In this experiment, I believe it was like four squares on a screen. And then when a specific square popped up, the patient had to react and click only when the square popped up at a specific time. And then so this is pretty much where you can see all the data. You can view certain things, your time scale on the bottom here. And this scale over here is your millivolt scale. So you can actually see how like the electrical potential of the neurons as they were firing. In this case, right now it's set to 80, and then we can change it down here. And then a couple of other things that we can do. So you can see right now I'm just clicking on these, and there's a couple of like places that are highlighted. And that's basically how we would extract the epochs, or as you can see from the button down here, reject the data if for some reason some of this data had a error in it, which I don't know if you guys how well you guys can see it. But I think this part, the big highlight over here, I actually think that's an error. Might not know what I'm talking about, but I'm taking a guess. Yeah. And then we can also do a bunch more. So if we go to the channel locations under the plot menu again, we can also see, we can plot the electrodes by name and by number. And so if we click by name, this is literally where all the 32 of the electrodes were placed on the scalp. And also, I believe these EOG2 and EOG1, I believe those are reference electrodes. So those are placed on the body just for like a baseline. And then this is the scalp, and you can see where everything's placed. Let's see what else. Channel locations by name, pretty much the same. Then we can also do a bunch of other things. We'll get more into like what these things actually mean and what they're used for. But if nothing else, like, go in, play around with it, figure it out as much as you can before the tutorial. It's just kind of fun to play with. You can see down here, we also have the time frequency transforms so that we can do the transforms right in EEG Lab and avoid the math, which is great. But so if we go, let's say, okay. Well, the data set doesn't have that, but we can do a lot with this. And we can also change the sampling rate of the data. We can apply a filter to our data right here from the GUI. We can re-reference the data, which, we're going to go over all this later once we actually, so that we can better understand like what they mean and how to use them. We can decompose the data into individual components. ICA stands for individual component analysis. And that's really, that's important for like understanding and viewing specific events related to your EEG data. We can extract data. Then, we can do a lot. We can also append different data sets to the current data set. And then let me import, you can actually import multiple different data sets. So I just imported a second one right now. And then well, now here you can see number 2. This is the second data set, second EEG data that I imported. All the same information, but here you can switch between the data sets or do both of them if you're, say, you have multiple trials or multiple patients. So you can move back and forth between each data set and do the exact same thing. So, we can, for this one specifically, here's the epochs for certain epochs for the taken from the first data set. So I don't know if you guys paid attention or noticed it, but the time scale is different here. So everything in between these dashed lines are actually different data sets as opposed to one continuous data set from the first time. Yeah. And so, yeah. And so that's basically that's pretty much the basics of EEG Lab. I just really wanted to go over, kind of show you guys how you can, first of all, get EEG Lab, download it, and kind of start playing around with it. Next week, we're really going to start doing more of the bulk work, which is going to be more of the stuff like we're going to get into the pre-processing. So actually filtering your data, amplifying data, and kind of actually starting to do the real work with EEG Lab. But for now, this is pretty much all that I wanted to show you guys. I will keep recording though if you guys have any questions, and I'm going to keep playing. I'll just record myself playing around with EEG Lab just so that people can kind of see what's going on. But yeah, like I said, next week we're going to start doing the actual pre-processing, which is mostly going to involve importing. It's also going to involve importing different types of data as opposed to just the set files. But yeah. Hey, you guys have any questions? Everyone understand, first of all, like, and kind of can see what EEG Lab is capable of? Yeah? Yeah, honestly, I think it's a pretty cool toolbox. It's kind of sad that no one at UIC uses it. But either way, especially if you guys go into research, I think this is going to be a really powerful tool for you guys to know and learn. But yeah, you guys have any questions? No? Has anyone downloaded EEG Lab in the midst of this tutorial? No, that's all right. Well, yeah, so that's pretty much all the actual content I wanted to show you guys today. Hold on. Where can we download it from again? Yeah, for sure, Stefan, no problem. So honestly, I shared the links, the second link on the chat for those who didn't notice or who didn't hear. The second link is a Google Sheet where it's an attendance sheet. So if you can fill that out, please do. And then on the second sheet of that Google Sheet, there's a link for EEG Lab where you can download and where you can go to the EEG Lab website, follow the prompts and download it. And then Safa, if you want, I can go over it again. If not, it'll be in the recording after it's uploaded. But depending on how you download it, you might need to set your path, which is a pretty straightforward process. Also on that second sheet, there's 2 links for different kinds of data that you can play around with. And besides the data that EEG Lab gives you, some of them, one of them is like just a database, and then the other is like from Open Neuro, which is an experiment and like different patients, different trials. Yeah, so I hope I answered your question.
When I tried downloading the EEG Lab, it's telling me that it can't be downloaded. It says it can't be downloaded securely.
Oh, okay.
I tried the compiled version part, and it said the same thing, and then I tried the other one.
Okay. Yeah, honestly, I think it said the same thing for me. Just hit the prompt and like hit download anyway. if you have like the little bar on the bottom where it like tells you that it can't be downloaded, there should be like an arrow where you can click and be like, it should like, there should be like a button that says a command that says continue, and you can just do that so that you can download it.
Oh, I think I found it.
Perfect. Yeah. But yeah,
Yeah.
no, even if it's not a secure file according to your laptop, it is a well-documented toolbox, and so you should be fine.
Okay.
I got that same error and I just kept going, but then I couldn't open it because it said it's from an unidentified developer. So should I just change my preferences to let me open apps from an unidentified? Okay.
Yeah. Just for the just for that one toolbox, it should be fine. Yeah. Thank you, Haley. But yeah, all right, guys. I'm gonna stop sharing my screen real quick, and then just see if you guys have any questions. But yeah.
Christian, personally, I think you did an amazing job. I had a very good time. Although I already knew how to use it, so I'm biased. But
thanks, Haley. And I don't just say that because you're also on the board, but but thank you. Yeah, no, I'm gonna stop recording. All right.